Thanks again for everyone joining. So today I would like to share something about the Gravitino and using Gravitino to build a agentic data platform. So our Gravitino is used to be a data catalog. So but as the agentic things or AI explore so much, and we want to find some new areas. So thinking of how metadata can enable the agentic data platform. So today I would like to present a thing what we have already done and what we are working on about using the Gravitino to build an agentic data platform. And I also have some demos to show you that how to use this to drive the daily work of the data engineer or data steward. So before the talk, let me quickly introduce myself. So my name is Jerry Shao. So I am the co-founder and the CTO of Datastrato. So, and also I am the original creator of Apache Gravitino. And besides, I'm the committer and PM's member of Apache Spark and Apache member. So I have a long experience on the big data area. So yeah, so our Datastrato, so our company, we began with solving the data silo problems because we think that data silo problem is a long-lasting problem and hard to solve problem. So data is siloed, not just because of data stacks we choose to solve different data problems. Like you use the Hadoop data lake to solve the batch query and ETL things, and using some others like to solve the ad hoc query things. So that's one data silo, and but also it is siloed by different cloud providers because we want to avoid single point of failure and achieve high availability. So we'll probably choose different multi-region or multi-region or multi-cloud solutions. So by nature, the data is also siloed regionally or cross clouds. And even further, so for big companies, their business is globally. So the data is siloed geographically because of the regulation and policies from different countries. So this kind of problem is inevitable, and the traditional way we are using like moving the data from different places to centralize the data to try to solve this data silo problem. It seems not achievable. So so how to solve this problem? And so we propose a new way because we think that the data should have a metadata. So instead of centralize all the data together to solve the problem from the physical layer, we are trying to solve it from the metadata layer. So with this idea, we bring out our project, which is called Apache Gravitino. So Apache Gravitino is a catalog of catalogs, and you can treat it as a federated catalog. It sits on top of existing catalogs, for example, like Hive Metastore and other catalogs, schema registry and model registry. So on the top, it provides a unified layer to manage the metadata. So no matter different engines, core engines, different users, they can fetch the metadata from Gravitino in a unified way. They can get the tabular data, non-tabular data, and others. So with this, we are building a unified metadata layer. We call it a metadata lake. So this can achieve a lot of new features that cannot be done previously. For example, like single source of truth from metadata layer. So it is easy to attain that. And also, we are not just a traditional tabular data catalog. We can also manage AI data like unstructured data like models. So we are AI plus data catalog. And also, we can support like multi-regional deployment, so you can fetch metadata from different areas, manage metadata from different areas. So and it can give you a unified view. So it is by nature can handle a geographic issue, and also we provided some like governance-related features like lineage tagging and classification and something like this. Also, we provide centralized security things like we provide RBAC security in a centralized way. So you don't have to define security everywhere, and using Gravitino can define the security things in one place and apply it to the different engines. So this is Gravitino. So you can treat it as a catalog. So so we want Gravitino to be a open catalog or standard for open catalog. So we think that Gravitino, it is better to be maintained in an open source way. So with this, we donated the Gravitino to the Apache Software Foundation in the 2024, and within the less than 1 year's incubation, and in last year May, we graduated from the Apache incubator and become a top level project, and we still evolve, and in the last September we released the 1.0, which is a remarkable release, and we'll continue release and add new features and release new versions. And currently the latest major release is the 1.1, and we are working on the 1.2 release, and it will be out in the February, in the end of February. So so we have done a lot, and especially in the data catalog area and AI plus data catalog, federated catalog area. So the question is that what is next? What can we do? And especially in the AGI era. So taking a look at this this chart, it is quite classic. It is which is called a modern data architecture from the X16Z, and you can see bunch of components. And if you want to build a modern data stacks for different purpose, you have to introduce many different tools and components. Modern data architecture is quite like a Lego system. You have to bring a lot of things to build this one, and this is actually quite complex, not only for the users like data engineers, analysts, and scientists, but also for like maintainers like data steward and data ops engineer. So it is quite complicated for the users. But nowadays, and the users are not human, not only human, but also like LLM, AI, and agent. So it is also quite complex for the AI and an agent to use it. So another trend is that, as Jensen Huang mentioned, that in the future of the work, so we probably already have that trend that each one engineer will have like a lot of the AI agent or AI assistant around him to help him to solve the problems, to do the daily works. So which means that we will probably have a lot of AI agents that also needs to work with the existing data platform and to solve the problem and do the daily works. And so what that means is that we should make our platform not only face to the human, but also face to the AI agent. That's what we call the Agentic Data Platform. And we think that the next generation data platform should be an Agentic Data Platform. It should have a AI-powered knowledge base, which we call a data brain, in the center of the architecture, and use this data brain to make decision which table should be used and how to use it and to do what kind of works. And surrounding this data brain, and we will bunch of tools and to fulfill or to handle different scenarios like ETL tools to handle the batch processing works, to do the daily to generate like batch report, and also like governance tools with observability tools and others. So it is all surrounded by a data brain, and using this data brain to make decision which is the right process to handle the right data to do the right thing. So that is Agentic Data Platform. So with this, I would like to share a demo about how we use Gravitino to build an Agentic Data Platform to solve the daily work. So the first scenario is like a data engineering daily work. So typically a data engineer, so his daily work is to build a data pipeline based on the requirements. So typically he will like get the requirement from others like product manager and others, and explore the related data, and then to test and build the pipeline and to check if the pipelines work or not. And if it works fine, and then it will generate the DAG and submit DAG to the DAG systems like Airflow and others. So that's a daily work. It should do this daily. And the lot of things are the investigating, the understanding the requirements, and also to explore the related data. So because in a typical data-driven company, so you have a bunch of data, a bunch of tables, you probably don't know which table should be used. So let's shift this this data pipeline works to AI, using the AI to drive. So the thing is that we have two agents. One agent is meta agent. We use meta agent to discover the metadata, to find which table should be used to build the pipeline. And we have another query agent. This is actually to run the query, and the data engineer just talk to the LLM. So what kind of things you want to do, and the LLM will decide will split down the plans and call the right agent to do the right things and get the result and submit the result and make it down. So here is a demo. So let me speed up, and I'm not sure if you guys can see the screen because it's not so clear. So yeah, so let me share the background of this demo. So the background is that we have a bunch of tables, that row table, sales table. Sales table means that we typically we store it in the transaction database. So we have some like different kind of products and different customers and the sales record and store record and stored in the as a different tables in a database. So here is the UI of Gravitino. Actually, Gravitino can manage the different tables from different sources. So what we want to do is that we will do a ETL pipeline to extract the row table and build a medallion pipeline, and with this pipeline, I will generate daily report. So as you can see here, this is related tables and schemas, and we use Goose to do the demo. And backed by Goose, we have several agents, like I mentioned, 2 agents. So I will give a requirement to Goose that I want to get the top 10 sold products in each year. So, and also I split it down into the different steps so Goose can follow these steps to do the real things. So so the first step is to analyze the related tables, and then to verify the data quality, and then to build the pipeline. And after the pipeline is done, and we will generate a DAG, and then to submit to the Airflow. So the first step, we will call a meta agent to get the metadata from the Gravitino. So as you can see, the agent will explore the data and try to know the relationships of the table, and then he will also call the query agent to know if there are some data quality issues in the tables. As you can see that actually there are some columns they have empty values. And after that, the query agent will try to build the data the layer data pipeline, like ODS and the DWD and the DWS, different layers, and use the query agent. And then it will do the ETL things to actually load the table from layer to another layer, and to build the data pipeline. Yeah. So here, as you can see, and the agent is calling the LLMs calling the query agent to do to build a data pipeline and verify the result. And after everything is done, and the agent will try to formalize this pipeline and to generate DAG. So here, as you can see, we use iceberg table. So so after we we build the pipeline. As you can see, many tables. This is actually a table generated by this by the agent, so it can use to do the daily pipeline. So after everything's done, we will generate Airflow DAG. So Airflow DAG will be submitted to the Airflow and run daily. So this is a finalized pipeline, and this is a typical workflow for the data engineers to do the things, to do the data pipeline things, and in every day. Yeah. So yeah, this is one of the example, like using the data agent, or using the agent we provided, and to handle one of the scenarios for the data engineers that do the things daily. So another scenario is that for the data steward, they typically, their daily work is that they have to identify the sensitive data and label the data with the sensitive tag, and also enforce the policy on such tables, and to avoid something like sensitive information leakage or something like this. So typically, a data steward will doesn't have a strong background of the laws and regulations, so he will talk to like lawyers and others to know the better understand the details of the regulations, and then to identify the table, which table has sensitive information, and what kind of labels should be labeled on that table, and based on that label, so what kind of masking things should be done on the tables to fill out the sensitive information. So with this, and we can also use the agent to do these things. So we have like 3 agents. One is meta agent. Meta agent, as I mentioned before, it is mainly used to discover the metadata, to find the right table. And then we will have a governance agent. It will try to identify the sensitive information and put lag on that tables and others. And it will like query agent to verify if the data mask is actually working out. So here is also another demo. So here is we have like several tables from the HR department. So which means that there is a lot of sensitive information. So like employees personal information, like address, phone number, email, something like this. Also like salary and others. So typically for others, if they want to query that table, that kind of information things should be filled out. So what we did is that we also use like agent to do these things. So we will tell the agent that you are data steward. You need to identify sensitive columns, and then to associate a proper tag on that columns, and then based on that column, then to do the data masking things, and query the sensitive data if it is actually masked, and then get summarized and get the report. So that's the data steward work. But then the first step is still quite similar. So the meta agent is trying to understand this relationships, the columns, or the meanings of this bunch of tables, and then it will try to check using for example, like GDPR compilers to know, so what kind of which column is a sensitive column. For example, like name, like address, like rating, like performance rating, or something like this. And it will list all the available tags and try to apply the proper tags to that column. So it is just currently, so when the agent identifies the proper column and proper tag, it will associate all the tags to the proper columns. And then the query agent will trying to query the data. So as you can see, the sensitive information is already filtered out. Mask and yeah. And it can still get aggregate data because the aggregated data just lose some personal information. So if you query the aggregator, still can get the correct answer. So that's also that also works if even if data is masked, or even if the label some sensitive column is labeled. So that's a data governance demo. So you might be curious how we did. So let me show you some of the details of our architecture. So what is the agentic data architecture? So we think that to build an agentic data architecture, the key thing is the metadata. That's why we extend Gravitino to this area, because we think that metadata is a data of data. So with this metadata, we can do like contextual understanding and discovery, and we can do the coordinates and governance, and we can even trigger do the decision making and automation based on the metadata. So what it means that is the metadata is a bridge between the LLM and data, because when you query the table, when LLM query table, and the LLM doesn't actually know the details of the table content, like it's a bunch of digits, so it doesn't have any meanings. So with this metadata, we can actually do a lot of things for LLM to understand the semantic meanings of the table and then do the right things. So that's why metadata becomes much more important to build a agentic data platform. And also we leverage Gravitino to do these things, because Gravitino by nature manage all the data from different sources and provide a unified way. And with this, so we bring out a new concept which is called like metadata centralized architecture. So previously, when we build a data stacks, we often build a data stacks with engine centric. For example, if we want to solve the like batch problem, we will pick like Spark and others like to solve the batch problems. And if we want to do ad hoc things, we will using like Trino and others to solve ad hoc things. And the catalog is kind of the one of the component embedded in the query engines. So it is not a first-class citizen. So, but in here, because everything should be driven by the metadata, so metadata becomes a very important layer. So what it means that we should build a unified metadata layer, and with this metadata layer as a centralized place, and then to trigger the engines to do the right things, and all the query engines and other things, we will make them as a tool, and for example, like MCP tool and other agentic framework tools, and triggered and invoked by the agentic framework, and then to build the different agents. So again, so metadata will be now the centralized place. So how do we do in the Gravitino? So Gravitino in the before the 1.0 version, it is actually a metadata catalog. So it can manage the metadata in a centralized way, and no matter it is tabular data, non-tabular data, and others. But treat this as a brain of a human. So we still need arms and legs to do the actions. So in the 1.0 version, we added a lot of enhancement to add more things. The first thing is that we also enhance the metadata to enrich the metadata. So we add statistics support and others. So and still we can add more semantic or this metadata into the associated with existing tabular metadata. And on the other hand, we build a tool framework, which we call action framework. To actually, you can build the tools, and these tools will be associated with metadata. So the LLM can, based on the table they want to process, and pick the right tools to invoke tools and do the actions. And so we have the like arms and legs, but it is not enough. And we also add a policy systems, because LLM will do the evil things. So we kind of build a guardrail for the like policy systems for each metadata. So you can define and personalize your policy information on tables, and enforce enforce some specific actions. Yeah. So this is the Gravitino 1.0 plus. We already have several components, and if you can take a try. So this is kind of like like backbones for the agentic data platform, but still it is quite difficult for the users to use because there are a lot of development works. So we make it everything like MCP, using MCP to export all the tools, and also to build like different agents. For example, like we have like policy agent is mainly for the policy related things, tools to manage policy related tools, and for the LLM to understand which kind of policy should be enforced to which table. And the meta agent is mainly for the metadata things, and the action agent is actually for calling the tools, specific tools. And with these different agents, you can combine them together and add your own logics and to build different agents like data ops agent and data engineer and other different data specific agents. So this is kind of the building blocks for the agent things, and we think that with our Gravitino, we already support like metadata. We can further push the Gravitino to the next level to use Gravitino, to use metadata as backbone for the agentic data platform. So with this, we provide a lot of building blocks. The first thing is that we provide a knowledge base, and which is for users to build a data brain. So we still enrich, add more lot of metadata support like statistics and job metrics and other support. So you can store a lot of not only just the physical table related information and others to the Gravitino. So this will be leveraged by OM to understand the meanings, semantic meanings of tables and others. And the second part is that action tools, we add jobs and function support. So LLM can call the function directly from the Gravitino. They don't have to involve others. And Gravitino will better manage it, not just the metadata, but also the action tools. And with these tools associated with metadata, LLM can actually call the right tools to the right things. And also we have like policy enforcement for the agent to do the guardrail things and to make sure it doesn't do evil things. So all of these things will help users to build a data agent and with Gravitino as a one-stop solution. Yeah, I think that's all from that's all about the talk. So if you want to join our workspace, you can scan our QR code. And our project is Apache project. You can start, and also if you want to explore more, so you can click the link. Yeah, that's it. Thank you. Huh? Yeah, we provide an MCP library and an MCP server in this project. You can check it. Yeah.
Do you mind?
Yeah.